So welcome. So this is CAIE June 2005 paper of P3. We shall solve all the 10 questions. There are 10 questions, but basically the 10th question is from vectors, which has been moved to further math. So we will be solving only the 9 questions without vectors question. So let us try to solve it now. So coming to the first question. So from binomial expansion, 1 plus 4x whole to the power of minus half. So for this only just the formula we need to know. 1 plus x whole to the power of n is equal to 1 plus nx plus n times n minus 1 upon 2 factorial x square plus n times n minus 1 times n minus 2 upon 3 factorial x cube and so on. Because he is asking up to x cube, so we are writing it out the 4 terms till x cube. So over here comparing, n is equal to negative 1 upon 2 and x is 4x. So then we plug in the values now. It becomes 1 plus n is negative 1 upon 2, x is 4x plus negative 1 upon 2, negative 1 upon 2 minus 1 upon 2 factorial, 4x whole square plus negative 1 upon 2, negative 1 upon 2 minus 1, negative 1 upon 2 minus 2 by 3 factorial, 4x whole cube and so on. So this is all just basic calculator based calculations. I'm directly writing the answer. 1 minus 2x plus this becomes 6x square and this becomes negative 20x cube plus and so on. That's going to be the answer for question number 1. Question number 2, it's from trapezium rule. So for trapezium rule, what we need to do it is we have to find it out first a value, which is the lower limit, minus 0.6, b value, which is the upper limit, plus 0.6, 2 intervals. So n is equal to 2. So we have to calculate h value. What is h? B minus a upon n, which is 0.6. Minus of minus 0.6 is plus 0.6 by 2. So h value is 0.6. Once I get that h value, so I need to draw a table. So let me draw a table. So very simple table. I got those values of x and y. So start with a, which is minus 0.6, then add h to it. So it becomes 0, then again add h to it. So it becomes 0.6. Once I get the upper limit, stop there. So now I need to get the y values. We know that y is equal to 1 upon 1 plus x cube. So first I'm going to plug in negative 0.6 whole cube. So when I plug in negative 0.6 whole cube, so I'm going to get it as 1.2755. I write there. Next I plug in 1 plus 1 by 1 cube, so 0. I'm going to plug in 0, so it becomes 1. Then I'm going to plug in positive 0.6 whole cube, so I'm going to get 0.8223. So I got these values. Now I have to use this trapezium rule formula, another simple formula. So let this be y0, y1, y2. So the formula will be h upon 2 times y0 plus 2 times of y1 plus y2. So first term plus last term, first and last term should be added and the middle term should be multiplied by 2. So h is 0.6 upon 2. The first term is 1.2755 plus 2 times 1 plus 0.8223. So when I simplify this, again I'm directly writing the answer. It should be 1.23. Now coming to the second part, let me check it out. What is this second part is? Second part is asking, explain with reference to the diagram why the trapezium rule may be expected to give a good approximation of the true value. So we go to the diagram, we zoom in the diagram, then we try to draw the trapezium over there. This is the trapezium. I'm drawing the trapezium. You can see that I am overestimating over here. This is called overestimation. I'm getting some part of area extra. Whereas I go over here and draw the trapezium, you can see over here I am underestimating the area. So it is both overestimation and underestimation. So they both get cancelled each other. Overestimation and underestimation cancel each other. The extra area which I'm getting on the left side is being cancelled with the less area what am I getting on the right side. So you can write it out that one in the same way. What you can write it out is one trapezium overestimates the area and the other trapezium underestimates. Both cancel out. Hence, no error are noticed. Okay, so that is the answer. You are going to write it out for that part. Coming to the third question, it's from complex number. It's a quadratic equation. So a is equal to 1, b is equal to negative 2y, c is equal to negative 5. So I use the formula minus b plus or minus square root of b square minus 4ac upon 2a, 2 times 1. So over here when I'm using b square, you can notice that I did not use minus. If you want to use, you can use minus, because anyway minus whole square is plus. So I try to solve it out over there. 2i plus or minus square root of 4i square plus 20 divided by 2. 2i plus or minus square root of 16 divided by 2. So it becomes 2i plus or minus 4 divided by 2. So I get two roots. What are those two roots? One root is 2 plus I and another root is minus 2 plus I. So let this be z1 and let this be z2. So I got two roots, 2 plus I and minus 2 plus I. And what is being asked? Find the modulus and argument of each root. So I find it out the modulus of z1, so which is square root of 2 square plus 1 square, which is root 5. Argument. For argument, what am I going to do? I'm quickly drawing the Argand diagram. Okay, so let me draw the Argand diagram over here in the middle for both, so that it will be useful. This is 2 plus I. This is 2 and this is 1. So this is angle is theta. So tan theta is equal to 2 upon 1. Theta is equal to tan inverse 2. So theta is equal to 26.6 degrees. If I want to write in radians, 0.464 radians. Now for z2. Let us go for z2. So modulus of z2 is equal to square root of again 2 squared plus 1 square, which is root 5, the same modulus. Then z2. So where should I do? Minus 2 plus I, right? So it comes over here. This angle is theta, minus 2 and 1 is already there. So then what am I going to get it out is tan theta is equal to 2 upon 1. Theta is equal to tan inverse 2, which is 26.6 degrees. But argument means it is angle from the positive x-axis. So positive x-axis. So argument of z2 is equal to pi minus 26.6 degrees. So which it becomes 153.4 degrees or 2.68 radians. Over here also we have to write in proper form, argument of z1 is equal to 26.6 degrees. So this is going to be the answer, z1 and z2. Question number 4. Use the substitution x is equal to tan theta. Substitution x is equal to tan theta. So x equals tan theta. So dx equals tan theta derivative is secant square theta d theta. So I plug in 1 minus tan square theta divided by 1 plus tan square theta whole square. Dx is secant square theta d theta. So 1 minus tan square theta, 1 plus tan square theta is secant square theta whole square times secant square theta d theta. 1 secant square theta gets cancels. Now next 1 minus tan square theta is sin square theta upon cos square theta divided by secant square theta is 1 upon cos square theta. So d theta. So what does that becomes now? Cos square theta minus sin square theta upon cos square theta by 1 upon cos square theta. So and d theta. What can you see is cos square theta cancels. So I'm left over with cos square theta minus sin square theta is cos square theta minus sin square theta d theta. What is cos square theta minus sin square theta? Is cos 2 theta. So I have proved it out. It is cos 2 theta. Now he's asking us to find the integral. This and this is the same. So what am I going to do? I am first find the lower limit. Lower limit means LL. Lower limit LL. X value is 0. So 0 is equal to tan theta. So theta is equal to tan inverse 0, which is theta is equal to 0. UL upper limit. UL means upper limit. What is upper limit? 1. 1 is equal to tan theta. So theta is equal to tan inverse 1. So theta is equal to pi by 4. So I got the lower limit and upper limit. Then I try to find the integration 0 to pi by 4 cos 2 theta d theta. So integral of this one, cos 2 theta is 1 upon 2 sin 2 theta from 0 to pi upon 4. So plug in 1 upon 2 sin times 2 times pi by 4 minus sin times 2 times 0. So 1 upon 2 sin pi by 2 minus sine 0. So 1 upon 2, 1 minus 0. So answer is going to be 1 upon 2. That's question number 4. Question number 5. The polynomial x squared plus x power 4 plus 5x plus a is denoted by p of x. So let me write p of x is equal to x power 4 plus 5x plus a. It is given that it is a factor. So factorize and find the value of a and factorize this one. So we have to find the value of a and factorize it. Okay. So what am I going to do? I'm going to do the long division. X power 4 plus 5x plus a divided by x square minus x plus 3. So how should I do the division? So every time, see carefully long division. Whoever is not perfect with the long division, they can go through this part very carefully. Take the first term inside, first term outside. X square should be multiplied with what to get x power 4. So cross check. X square should be multiplied with what to get x power 4. X square should be multiplied obviously with x square. So what am I going to do? Multiply with x square. So multiply all the three things with x square. So it becomes x power 4 minus x cube plus 3x square. Then what am I going to do? Change the symbols. Minus plus minus. X power 4 gets cancels. This is x cube minus 3x square. Carry down that minus plus 5x also. Okay, and you can carry down that a also, doesn't matter. Okay. So now that is the first part of the multiplication. Now the next part of the multiplication. So let me erase all this part which is not required. Okay. So now I am going to take it out. X square should be multiplied with what to get x cube? X square should be multiplied with what to get x cube? Obviously this should be plus x. So I write plus x. So multiply all the 3 with plus x. So it becomes x cube minus x square plus 3x. Then again I change the symbols, minus plus minus. So I see x cube gets cancelled. So it becomes negative 2x square plus 2x plus a. Negative 2x square plus 2x plus a. Then what am I going to do? I'm going to erase this part so no confusion. Now again we change for a color. This time this color let us choose. X square should be multiplied with what to get minus 2x square? X square should be multiplied with what to get negative 2x square? So it is just negative 2. So when I multiply with the negative 2 all the three, negative 2x square plus 2x minus 6. So change the symbols, plus minus plus, so they get cancelled, a plus 6. So this is my remainder. Because he says it is a factor, remainder is, the final thing is called remainder. The remainder is a plus 6. It should be equal to 0. So a is equal to negative 6. That is the value for a. Now hence state the number of real roots. He's asked, and factorize completely. So we have to factorize it out completely. So what we got it out? We got the total equation as x power 4 plus 5x minus 6. X power 4 plus 5x minus 6 is equal to, the factor was x square minus x plus 3 times, we haven't written, right? So whenever we are writing it out, this division, don't forget to write that one at the top. So first time I multiplied with x square, second time I multiplied with x, then the third time I multiplied with minus 2. So x square plus x minus 2, x square plus x minus 2, that is the factor. Now we have to factorize this one also further. So x square minus x plus 3 times, this is x plus 2 times x minus 1. This is the answer. Now hence state the number of real roots of this equation, justify your answer. So how many number of real roots are there, and justify your answer. So we could able to see these are the two real roots. This cannot be further factorized, so therefore, or we can try to do that. For this one I find b squared minus 4ac. So 1 square minus 4 times 1 times 3, which is 1 minus 12, which is minus 11, which is less than 0. So no real roots for this part, but over here I have two real roots. So therefore there are how many real roots? There are two real roots. For this other quadratic factor, there are no real roots. Question number 6. Prove the identity cos 4 theta plus 4 cos 2 theta is equal to 8 cos to the power of 4 theta minus 1. So cos 4 theta plus 4 cos 2 theta. So cos 4 theta. So first of all, we'll find the formula for cos 2 theta. Cos 2 theta formula is, I want everything in terms of cos, right? 2 cos square theta minus 1. So basically then cos 4 theta will become 2 cos square 2 theta minus 1 plus 4 times cos 2 theta formula is 2 cos square theta minus 1. You can see that angle becomes half. Half of the angle, 4 theta becomes 2 theta, 2 theta becomes theta. Now again this is 2, again cos 2 theta formula, 2 cos square theta minus 1, but still I have a whole square, so whole square minus 1 plus 8 cos square theta minus 4. So 2, this expand this one, a minus b whole square, a square minus 2ab plus b square plus 8 cos square theta minus 4. So it becomes 8 cos to the power of 4 theta minus 8 cos square theta plus 2 plus 8 cos square theta minus 4. We can see that 8 cos square theta gets cancels, and my final answer which is required is 8 cos power 4 theta, but I require it out is this minus 3. So over here what has happened is we have forgot this minus 1. So minus 1. So it becomes minus 5 plus 2 is minus 3. So my final answer goes as 8 cos to the power of 4 theta minus 3. That's going to be the final answer. Now solve this equation between 0 to 360. What is that equation? Let me write that one equation. The equation was cos 4 theta plus 4 cos 2 theta is equal to 2. Just now we have proved this part is equal to 8 cos to the power of 4 theta minus 3, so is equal to 2. So from there I get 8 cos to the power of 4 theta is equal to 5. Cos to the power of 4 theta is equal to 5 by 8. Cos theta is equal to 4th root of 5 by 8. Now I take the 4th root of 5 by 8. So let me quickly take the calculator. Then it says 4th root. Where is that? 5 upon 8, and theta is equal to cos inverse of 4th root of 5 upon 8. So 4th root of 5 upon 8. So when I find that 5 upon 8 value, I'll be getting it at 0.889. So theta is equal to cos inverse of plus or minus, don't forget to take plus or minus, 0.889. 889, three significant figures. I have taken 0.3889. So when I do shift cos inverse of the plus 0.889, I get 27.2. So I get two answers, right? I take positive answer 0.889 once, and I take the negative answer once, cos inverse of minus 0.889. So this gives me alpha is equal to 27.2 degrees. And if I do cos inverse of minus 0.889, it gives me 152.75 or 8. Alpha is equal to 152.8 degrees. Now for cos, remember, for cos the general solution is 2n pi plus or minus alpha. 2n pi plus or minus alpha. So my theta I do 2 times, so theta is equal to 2n pi plus or minus 27.2 degrees. So n is equal to 0. So remember, pi means 180 degrees. N is equal to 0. I get plus 27.2 degrees and minus 27.2 degrees. Then n is equal to 1. So 360 plus 27 is 387.2 degrees, and 360 minus 27.2 gives me 332.8 degrees. 332.8 degrees. You can clearly see that the range given in the question is between 0 to 360. 0 to 360. So therefore this is done, this is neglected, this is neglected or rejected, this is done. So I get two answers from here. Then I go to the next part. Theta is equal to 2n pi plus or minus 152.8 degrees. So n is equal to 0. I get positive 152.8 and negative 152.8. N is equal to 1. 360 plus this one is 512.8 degrees, and 360 minus 152.8, which gives me 207.2. So again I see that I consider this, I reject negative 152.8, reject 512, consider 207. Okay, so my final answers will be, write all in an order, 27.2 degrees and 152.8 degrees, 207.2 degrees and 332.8 degrees. So that's going to be the case. So quickly once again, for the people who wouldn't have understood what has all gone, so because I have still space to write it out, I can do that one over here. So when I get cos theta is equal to 2n pi plus or minus 27.2 degrees, so I substitute n is equal to 0. So 2 times 0 times 180 plus 27.2, or 2 times 0 times 180 minus 27.2. So I get it out over here, 27.2 degrees, over here minus 27.2 degrees. Similarly, when I do n is equal to 1, I get 2 times 1 times 180 plus 27.2. 2 times 1 times 180 minus 27.2. So over here I get 387.2 degrees. Over here I get 332.8 degrees. The range is between 0 to 360. So only these two angles are being considered. So similarly, I can do for that another angle also, and I get that one. So let us do that one also quickly. So theta is equal to 2n pi plus or minus, what was it, 152.8. 152.8 degrees. So when n is equal to 0, I get 2 times 0 times 180 plus 152.8, 2 times 0 times 180 minus 152.8 degrees. So which gives me 152.8 degrees, and this is 200 and minus 152.8 minus 152.8 degrees. Then I try n is equal to 1, 2 times 1 times 180 plus 152.8 degrees, 2 times 1 times 180 minus 152.8 degrees. So this becomes 512.8 degrees, or when I do this one, 360 minus 1 is 207.2 degrees. So again I see the range is between 0 and 360 only, so these two angles are being considered. Now question number 7. By sketching the suitable graphs, cosecant x is equal to half cos x has only a root between 0 to pi by 2. So cosecant graph. So how do I do the cosecant graph? So for that, what I have to do it is first draw the sin x graph. Whoever don't know the cosecant x graph, so for them, what is the easiest way is draw sin x graph. So approximately I am drawing the sin x graph. This is the way how does the sin x graph looks like. Okay, now what am I going to do it is I want to draw the cosecant x graph. So draw one asymptote at this point. Okay, so I drawn one asymptote over there. So let me draw neatly. Okay, do once again neatly. So first draw x-axis, y-axis. This is x-axis, y-axis. I am drawing x-axis, then drawing the sin x graph. This is the way the sin x graph is drawn. It's not coming. Smoother curve. Try to get a smooth curve. Okay, doesn't matter. This is x-axis and y-axis and then sine curve. Then draw an asymptote. So extend this line till here. So this is 0, this is 180, this is 360. Now once you drawn the asymptote, then what has it? There is one more asymptote over here also at y-axis. Also you can draw one more asymptote. Then what you can do it out is you can draw this upside down of this curve, upside down. So approximately in this way. Upside down of this one. So this purple color graph is going to be my cosecant x graph, and this value is 90 degrees because he's only asking up to 0 to 90. So that is my cosecant x graph. Okay, 0 to 90. So I take only a part of this cosecant x graph, so I don't require the entire graph, right? So that is a cosecant x graph between 0 to 360, but he's asking only between 0 to 90. So what am I going to do? I am going to redraw that part of the graph. Do I have a sufficient space? Wow, so much of space is there to write. Okay, so I'll do once again a part of the graph. I can see that it's coming down like this. So this is 0, this is 90. This is cosecant x graph, or pi by 2. Now that's cosecant x graph. The next graph that I'm going to do it is half x plus 1. So y equal to half x plus 1. If x is 0, y is half 1. If x is 0, y is equal to 1 when x is equal to 0. So this value we know it is 1, so this is 1. half x plus 1. Then I am going to draw a straight line. I'm going to draw a straight line passing through that point. I need to know the another value. If x is 0, y is 1, I got it out. If y is 0, x is equal to, I get it out as negative 2. So this may be negative 2. So I draw a straight line passing through these two points. I draw a straight line. This is the one, and we can see that both are intersecting at only one point. So we can raise that both intersect at one point, so therefore has only one root. That is the answer for the first part. Just 2 marks question. Verify by the calculation that this root lies between 0.5 and 1. So let me make f of x is equal to, bring cosecant x minus half x minus 1. Then substitute 0.5. So keep the mode of the calculator in radians. Then cosecant half x. So it is 1 divided by sine 0.5. Then minus half x 0.5 divided by 2, then minus 1. So I do cosecant half 0.5 minus 1 upon 2 times 0.5 minus 1. So when I do that one, I am going to get the answer as positive 0.8358. Now what am I going to do? I am going to do, what is other value of x has been given? 1. So go back and change the value to 1. Cosecant 1 minus half times 1 minus 1. So go back and change the values in the calculator from 0.5 to 1. So I have changed it out to 1. So I get negative 0.3116. So as f of 0.5 and f of 1 are having, so you have to write are having opposite signs, root lies between 0.5 and 1. Next part, show that this root also satisfies this equation, x is equal to sine inverse 2 by x plus 1. So part 3, it has been given cosecant x is equal to half x plus 1, and it has been asked us to prove x is equal to sine inverse, what was that? X is equal to sine inverse 2 by x plus 2. So we don't know how to do that. So what am I going to do? It is, I'm going to do bottom up approach. Bottom up approach means go backwards. So if this would have been the question statement, the before step would have been sine x is equal to 2 upon x plus 2. The before step would have been, I require it out cosecant x, right? So do the reciprocal on both sides. So 1 by sine x is equal to x plus 2 by 2. So 1 by sine x is cosecant x is equal to x upon 2 plus 2 upon 2. So cosecant x is equal to, see, 1 upon 2 x plus 1. So that is a way from bottom up approach we can get that answer. Next is asking, use the iterative formula taking the initial value x1 is 0.75. xn plus 1 is equal to sine inverse 2 by xn plus 2. So let us start. Okay, let me write over here. Okay, what can I do is first I clean up this one, create a space for this part so that okay. So coming to the part, he says xn plus 1 is equal to sine inverse 2 upon xn plus 2, and initial value x1 is equal to 0.75. It has been taken, x1 value, let us check, it is 0.75, determined to 2 decimal places, giving each iteration in 4 decimal places. So each iteration should be done in 4 decimal places. So let us start. So n is equal to, if I start n is equal to 1, so I get x1 plus 1 is 2, sine inverse 2 by x1 plus 2, so sine inverse 2 by x1 is 0.75 plus 2, so which becomes sine inverse 2 divided by 0.75 plus 2, so which becomes 4 decimal places, right? 0.188143, 4 places of decimal. Next one, what am I going to do? N is equal to 2, so it becomes x3 is equal to sine inverse 2 by x2 plus 2, so which is sine inverse 2 by 0.8143 plus 2. So go back into calculator and 0.8143 plus 2, so it becomes 0.7904. 0.7904. Now next n is equal to 3, so x4 is equal to sine inverse 2 by x3 plus 2, which is sine inverse 2 by 0.7904 plus 2. So let me do that. When I do 0.7904 and I got 0.7991. Okay, so I'm going to try one more. Let n is equal to 4, so x5 is equal to sine inverse 2 by x4 plus 2, which is sine inverse 2 by 0.7991 plus 2. So I go back and change in the calculator. 7991 becomes 0.7960. Okay, so I should stop here. Why should I stop here? So what is the reason I have chosen to stop over here? So I round it off to 2 decimal places. This has become 0.81, 2 decimal places 0.79, 2 decimal places 0.80, 2 decimal places to 0.80. You can see that it's repeating 0.80, so therefore the root is 0.80 alpha. Whenever it repeats in 2 decimal places, I can see that its answer is that one, so alpha is equal to 0.80. Now coming to question number 8. Use the partial fractions, find the integral of this one, find integral 4 marks. So first of all, partial fractions. 1 upon y minus 4 minus y is equal to a upon y plus 4 upon b upon plus b upon 4 minus y. So 1 is equal to a times 4 minus y plus b times y. So plug in y is equal to 4, so 1 is equal to 4b, so b is equal to 1 upon 4. Then plug in y equal to 0, 1 is equal to 4a, a is equal to 1 upon 4. So what will be the partial fractions for this one? 1 upon y times 4 minus y can be written as 1 upon 4 by y plus 1 upon 4 by 4 minus y. He is asking us to find the integral, so just apply integral dy on both sides. So it becomes 1 upon 4 ln y or ln y, 1 upon 4 ln 4 minus y. Don't forget to divide by minus 1. Integral of that one he is asking, and find the integral of that. So 1y plus c. Don't forget to write plus c. That's going to be the answer. Okay. So given that y equal to 1, x is equal to 0, solve the differential equation, this one. So he's asking solve the differential equation. What was the differential equation given? Dy by dx is equal to 4y times 4 minus y. So bring all the y terms on one side is equal to dx. Then apply integral on both. Just now the integral of this one has been given as 1 upon 4 ln y minus 1 upon 4 ln 4 minus y plus c is equal to integral of 1 is x. Okay, so it is given that y is equal to 0, x is equal to 1. Y is equal to 0, x is equal to 1. Y equal to 0, x is equal to 1, or y equal to 1, x is equal to 0. So the other way, because y is equal to 0 is not possible. So you have to be very much careful. Y is equal to 1, x is equal to 0. So substitute. So 1 upon 4, because ln 0 is not possible. So you have to be very careful. Okay, ln 4 minus y is 3 plus c is equal to 0. So ln 1 is 0. So c is equal to 1 upon 4 ln 3. C is equal to 1 upon 4 ln 3. So I try to simplify it out, go back and substitute this value of c over here. So 1 upon 4 ln y minus 1 upon 4 ln 4 minus y plus 1 upon 4 ln 3 is equal to cx. I got that. Now what is the question being asked? It is being asked, make y in terms of x. So we have to make y as a subject. So we can see that 1 upon 4 is common. So ln y minus ln 4 minus y plus ln 3 is equal to x. So ln 3y by 4 minus y is equal to 4x. So 3y by 4 minus y is equal to e to the power of 4x. So 3y is equal to 4e to the power of 4x minus y to the power of 4x cross multiplication. So 3y plus y to the power of 4x is equal to 4e to the power of 4x. Take y common, 3 plus 4e to the power of 4x. 3 plus e to the power of 4x is equal to 4e to the power of 4x. So y is equal to 4e to the power of 4x upon 3 plus e to the power of 4x. In these kind of questions, always remember that get e to the power of minus, so that why it is minus, I'll just show you. So what do? Divide by e to the power of 4x. Try to get e to the power of a negative number. Why is it? I'll let you know. So 4 plus 3 e to the power of minus 4x plus 1. I divided by e to the power of 4x. Why it is required, you can leave it out at that this step itself, but I just proceeded to divide it by e power 4x, both numerator and denominator. Try to get e to the power of minus 4x or e to the power of minus of x. Why? Because obviously in the next part of the question it is being asked, when y value, what will be the value of y when x becomes very large? So we know that, or we have to know this common thing, that e to the power of minus x tends to infinity. It will become infinity when x becomes very large. You can see e to the power of minus maybe 1000 or 10,000 is approximately equal to 0. So this entire thing becomes 0. So as x tends to large number, e to the power of minus x tends to 0. This arrow mark is tends to. So I'll be getting it out by value 4 plus 0 plus 1, so which is 4. So what y approaches 4, that's going to be the answer. So that is the way, or that is the reason why we should be getting it out, e to the power of minus of something, so that it always becomes 0 when x becomes very large. Question number 9. Find the x coordinate of m. M is the maximum point, means I have to find the first derivative and equate to 0. So y equal to x upon x square plus 1. So I have to find dy by dx. Dy by dx is equal to x square plus 1 whole square, x square plus 1, x derivative is 1, minus x times x square derivative is 2x. At maximum point, first derivative is equal to 0. So equate x square plus 1 minus 2x square upon x square plus 1 whole square. So it becomes 1 minus x square is equal to 0. So x square is equal to 1, x is equal to plus or minus 1. But because we see that x is a positive value, this is a positive value of x, so therefore minus 1 is rejected. So I will be getting x is equal to 1. This is the final answer. Find the area of R in terms of P. So it's starting from 0 to p, and I have to do the integration of this one. Area means integration. So for the part 2, integral 0 to p x upon x square plus 1 dx. We see that the denominator is x square plus 1. Its derivative should be present. So what I have done? Multiply and divide by 2. So there is a formula. If any denominator is there and in the numerator its derivative is there, then the formula is ln denominator. As simple as that. So it is 1 upon 2 ln x square plus 1 from 0 to p. Substitute that one now. Ln p square plus 1 minus ln 1. Ln 1 is 0, so 1 upon 2 ln p square plus 1. This is going to be the integration area. Hence, calculate the value of p for which r is 1, giving your answers to 3 significant figures. So the area is 1. So 1 upon 2 ln p square plus 1 is equal to 1. Area is going to be 1. Calculate the value of p for which the area is 1. So we got that area is equal to 1. So what do I get? Ln p square plus 1 is equal to 2. P square plus 1 is equal to e power 2. P square is equal to e power 2 minus 1. P is equal to square root of e power 2 minus 1. So let us do e power 2. E power 2 minus 1. So answer is 2.53. 3 significant figures. Answer is 2.53. So the p value is 2.53. There it goes. Question number 9. Question number 10 we are not doing because it is from vectors. Thus all the questions have been solved. That's it for this video. See you in the next video.